All right, homework 10 is translating trig graphs. So this time we still have the period and amplitude to talk about, but we also could have a phase shift or a vertical shift, and then that would shift a midline as well. So we're going to do the first two. I want to make sure we do a sine, cosine, and tangent graph. I also want to make sure we end up talking about every single one of these features during this little video. So first one, we have the sine of, and then in parentheses, we have theta plus pi. So the amplitude is still the number that's right in front of sine, cosine, or tangent. If there's nothing written there, it's 1 for sine, which is just the standard amplitude. Period, you would take whatever is in front of the cosine, and you would take 2 pi. So for sine, it's always 2 pi divided by whatever value is in front of the theta. So there's nothing there, so the period is still just the standard 2 pi. Phase shift, you look at what you've got in parentheses. Remember, the variable plus something is a movement to the left, so we are going pi units to the left. The vertical shift is if there's a separate constant not attached to anything, not in parentheses, and there's nothing there. So there is no vertical shift for this one. And if there's no vertical shift, that means the midline is still right around 0. Okay, so our midline is at 0. We've got an amplitude of 1. We do have a phase shift, so here's how that starts. The start of our very first period of the cosine, or the sine function, normally starts at the origin, right? But we are shifting the entire graph pi units over to the left. So that's going to be our starting point. Now let's follow through the rest of the pattern. All right, so now the period is 2 pi units. So here we go, 1 pi, 2 pi, and that's where our cycle is going to end. So this is the starting point and the ending point of our sine cycle. Now remember the way those 5 general points work. The third point is also right on the midline. Okay, so that's what we've got so far. The first point, the third point, the fifth point. Now the second point is up at the high. The fourth point is down at the low. So that, the high and low, we use the amplitude to determine. So our second point is at the high point, which is just going to be right there, just up 1 unit, because that's what the amplitude says. Our fourth point, I should say, is going to be down at the lowest value, which again is just according to our amplitude. So that's 1 cycle. So you just take that 1 cycle and you're going to end up repeating it. So it goes basically like over, you're going by pi over 2 every time. So this is the start of a new cycle. So it goes to its high point, back to the midline, and then would carry on down. Reverse this over here. So it goes low point, midpoint. So you can see this just rolling cycle of what this would look like. It's like that. Okay, let's also do number 2, tangent graph. So this one, the amplitude, remember, is undefined for everything except for sine and cosine. If there are vertical asymptotes, then you don't have an amplitude because you don't have a highest point or a lowest point. The period for tangent is always pi divided by whatever's in front of the theta. So there's nothing in front of the theta, so that's just going to be pi. The phase shift is if there's something in parentheses with the theta, the way there was here. So since there isn't any parentheses, there is no phase shift. The vertical shift is the number that's by itself, not attached to anything, not in parentheses. So this would be 4 units, and it would go down because it's -4. And so that would shift the midline as well. If everything's moving 4 units down, that would move our midline. All right, so where our tangent would normally have x-intercepts, it's now going to intersect that midline, right? So tangent would normally intersect right at the origin. So instead of intersecting right at the origin, it's going to intersect down here. Okay, and it would normally intersect at every multiple of pi, right? So instead of intersecting the x-axis, it would intersect the midline here, and here, and here, and here. So that's at every multiple of pi. Now, there was no phase shift, so where it normally had asymptotes before, that's exactly where it still has asymptotes now, because there was no shifting of the graph to the left or to the right. So normally, the tangent graph has asymptotes every pi over 2 times b, so just pi over 2. So these odd multiples, right? So 1 pi over 2, 3 pi over 2, -1 pi over 2, and -3. If you kept going, it would be at 5 and -5 pi over 2, etc. So it looks exactly like the tangent line graph looked before. Everything just gets shifted down. So it kind of comes up like this, this is where it turns around and heads towards the vertical asymptote. So you see a lot more of the top half. So coming up through here, like that. And it's just repeating. Remember, these functions are all periodic. So once you figure out what the shape is, you're just repeating that shape over and over again until you run out of graph. Okay, so that's what that one would look like. I want to do a cosine graph, and I want to do one that has a lot more going on. Let's look at number 6. All right, so this one, amplitude is whatever's in front of or attached to the sine, cosine, or tangent. So that would be an amplitude of 2. This means there's a little bit of a vertical stretch. It's going to go higher than normal and lower than normal. The period, you take 2 pi and you divide it by whatever is attached to the theta. So there's a 1/2. So 2 pi divided by 1/2 is the same as 2 pi multiplied by 2. So that's going to really stretch it out horizontally as well. It's going to take a lot longer to get through a cycle than it normally would. Phase shift, you look for parentheses. Think of your alliteration there. There are no parentheses, so there is no phase shift. Vertical shift is if there's a number that's by itself, no parentheses, not attached to anything. So that would be a 3. So that is 3 units. And since it's plus 3, it would be 3 units up. And finally, our midline shifts up 3 units as well. So instead of being at y equals 0, it moves up to y equals 3. All right, so midline, it's not a bad idea to put in like a little dotted line. You don't have to, but just so you kind of know that now the whole graph is centering around this point. So it's not an asymptote, but it's just to sort of guide your eyes to where your graph should be revolving around. All right, so normally, so there's no phase shift, right? So we still start right at 0 radians. So right at 0 radians, the cosine cycle starts up at its high point. Okay, so from the midline, our high point would be 2 units higher than that. Okay, so our high point would be up here at 5. Right, so that's the way this works. Then it goes through its cycle, and after it goes through its cycle, it would end back on its high point. It would end, though, 4 units later, or 4 pi units later. So that would be like all the way over here. So I'm not actually going to make it that far. I'm only going to make it halfway through the cycle. And halfway through the cycle would now be 2 pi. The whole cycle is 4 pi, so halfway would be 2 pi. And halfway, the cosine graph is down at its low point. So low point would be from the midline, we'd go 2 units down. So from the midline down here. So this is actually only half of our cycle. Okay, so this is really point 1 and point 3 of our cycle. We run out of room for 5. Looks like we run out of room for point 4 as well. Point 2 is right on the midline. So that is a quarter of the way through the cycle. Our cosine graph would be right on the midline. Okay, so you can see that little piece of it right there. So this is half of our cosine graph. We can actually reverse it back in the other direction too. So if you reverse it back here, this is like 0.4 of the previous cycle. And then this is like 0.3 of the previous cycle. So we'd have one cycle over here that went from high, middle, low, middle, high, and then this starts the first initial cycle. We just kind of run out of space. So just connecting our dots, try to make it nice and smooth. So it would look like that.